and then any other attendees can join in while we're doing the intro. Ade, you can go ahead and share your screen as I give out the introduction. So hello everyone and welcome to today's webinar session. We are very grateful to have you present today. We will be discussing insights derived from a market assessment that focused on the integration of brushless DC motors and permanent magnet synchronous motors in Nigeria in 3 value chains, and that is maize, cassava, and rice. This research was commissioned by the Efficiency for Access Coalition and led by the NOMAP team in Nigeria, who will be speaking today. The order of today's webinar will start with a presentation, which will be shared by Mr. Adedotun Eyinade, and then we'll have a panel where sector players will share some of their insights, and that will then be followed by a Q&A session. Our lovely speakers for today will be Mr. Adedotun Eyinade and Ms. Jennifer Anya from the NOMAP team, Mr. Samson Esuk from Nimsy Solar, and Engineer Godwin Ogaga from Afrimash. For some housekeeping, kindly keep yourselves muted and feel free to use the chat section to put down any questions you may have, and we shall address those during the session and also after during the Q&A session. So without further ado, I'll introduce our first speaker for today, Mr. Adedotun Eyinade from the Nigeria Off-Grid Market Acceleration Program, also known as NOMAP. He is an accomplished clean energy access professional with extensive experience in sustainable energy access, impact investing, and business strategy. And as a program director of NOMAP since 2018, he has spearheaded initiatives to accelerate off-grid energy access solutions in Nigeria. He has also worked extensively across Nigeria, Ghana, Uganda, and Tanzania, and he brings deep expertise in energy access and financial innovation. Over to you, Ade.
Yeah. Thank you very much, Shalom. Good morning, everyone. Greetings from Abuja, Nigeria. It's a pleasure to be joining this webinar this morning to talk about a very important topic, how we can integrate energy efficient motors into Nigeria's agricultural value chains. So I just run you through like the outline for the webinar. It's going to be I've got 15 minutes, I'm told, to run through a study that spanned about 3 months, thereabout. So I walk you through like an introduction, providing some background and context. For those of us that are not familiar with the agricultural equipment landscape in Nigeria, we'll give you a sense of it. We would also distill a high-level summary of the 3 value chains that we focused on during the study, and then we would look at some of the barriers against the adoption of brushless DC motors and permanent magnet synchronous motors in the 3 value chains. We would provide some of the recommendations based on our study, and then we'll talk about next steps. All right, so for those who don't, who are joining the webinar and not very familiar with brushless DC motors or energy efficient motors, what we've done is a study looking at these motor types. They're energy efficient. They save energy relative to and also cost relative to some of the existing or predominant motor types that are available in the market. So, I mean, as you have in Nigeria and as well as other markets in the global south, most of the folks that work in the agriculture value chains, there's a huge dependence on what you call induction motors. Induction motors are typically not very energy efficient, but they're widely used because they're available, and oftentimes they're more affordable, and that ends their wide adoption. So for background, of course we understand why we need to think of energy efficiency. Most of the context in which food is grown in the global south are places where the grid is either non-existent or the grid is weak, right? The context where people have little or no access to grid electricity, or when they do have access, the amount of hours of electricity they have every day is very, very weak. And we've seen the fact that you could get a lot of value, mostly energy efficiency value, in adopting what we call brushless DC motors. They are direct current motors, and then because they are brushless, it means that the amount of money that is spent on repairs pears associated with like the brush types is sort of like is almost non-existent when it comes to brushless DC. They are more you could control the speed, which in terms of other existing motor types like the regular induction motors, you don't have those advantages, and that means that they have specific they have use cases that can actually help in increasing agricultural productivity. So in this study that we conducted, we looked at the context of how these high efficient motor types can improve yield, can improve efficiency in 3 value chains. We look at the value chains of rice, maize, and cassava, and then you get to know why we focus on those 3 value chains in this study. So just to give you an idea of the methodology that we use and we adopted, I'm getting mindful of time. So we did a lot of desktop research. We had a number of interviews with stakeholders, and then of course, we documented our findings. In terms of the project objectives, we wanted to identify specific practices, agricultural practices in Nigeria that can benefit from the adoption of BLDC motors. One of the core objectives of the study is also to look at the current or the existing agricultural and technological landscape in Nigeria to identify potential partnerships and collaborations that can help to mainstream the adoption of these highly efficient motor types. In the course of doing that, we had about 24 consultations with various stakeholders, and we hosted 4 focus group discussions across 4 states in Nigeria. We spoke to about 16 companies, private companies working in the agricultural value chains. They range from mini-grid developers to equipment fabricators. We had some engagement as well with like about 4 development organizations, One Life Initiative, RMI, Haifa International. And of course, we also had some touch points with government institutions, like the Federal Ministry of Agriculture and Food Security in Nigeria, 1 or 2 state ministries of agriculture, a federal research institution as well. And this also gives you an idea of like some of the folks we interfaced with during the focus group discussions. Now, in Nigeria, there are quite a number of stakeholders that are working towards mechanization. I mean, those of us on the call will understand that the bulk of the folks involved in the agricultural value chains are smallholder farmers. But there are a lot of institutions and stakeholders that are working to ensure that we move towards mechanized farming. And they range from government institutions. You have the primary federal institutions with the mandate for policy formulation, which is the Federal Ministry of Agriculture and Food Security. You have a number of agric institutes in Nigeria that are also working to build capacity and ensure that Nigerians or farmers and various stakeholders adopt more mechanized options for agriculture. You have equipment fabricators, and those are very, very important stakeholders. You have OEMs, and you have a lot of development partners as well as financiers. Now, to just give you a sense, I mentioned earlier that we focused on 3 value chains in the course of our research. We focused on the value chain of value chains as cassava, maize, and rice. And you get to understand that in subsequent slides, why we decided to focus on those 3 value chains. In Nigeria, cassava is a very, very important staple food. Cassava is processed into a number of food items that Nigerians consume, from garri to fufu. And then of course, they also produce what is called high quality cassava flour, which can then be processed into other, end products like starch. Things like sorbitol. You can also be processed into things like ethanol as well. So it's such a very, very important, staple crop in Nigeria. And if you must know, Nigeria is also the highest, the largest, producer of cassava in the world. About 24 out of 36 states in Nigeria produce, cassava. So it's such a very, very important, food crop. So this snapshot just gives you an idea of like the various set of activities, across the value chain from the pre-feed up onto the post-feed. And there, some of those activities that also require motorized equipment, we've also sort of like highlighted them in this slide. Now, next is maize. Maize is also a very, very important, crop in Nigeria. We're said to be the largest producer of maize on the continent. The good thing about maize, the interesting thing about maize in Nigeria is about 40% of the maize that is grown in Nigeria is used to process animal feeds. So it's such a very, very important food crop. And in terms of some of the in-field motorized equipments that are used, in the maize value chain, you have things like the seed planter, you have water pumps, you have irrigation pumps, and you have the combined harvester. When maize is harvested, they use things like grain dryers. They're stored in silos. They use things like hammer mills to process them. They use dehullers, and then they of course they also bag them at the end of the day. For rice is also a major, food crop that has implications for our national security. And such the previous government in Nigeria ensured that for a while, we develop and deepen our local capacity to grow rice. But then the good thing about rice is that there are also opportunities for improving, the productivity or the yields and improve, and value addition, by integrating highly efficient motor types like BLDC and PMS. And you see in subsequent slides where those opportunities exist. So this particular slide would show you in just one view some of the opportunities for BLDC for high quality, high efficient motor integration into these particular value chains: rice, cassava, and maize. And for rice, some of the biggest opportunities exist along the lines where we want to dehusk, we want to shell, we want to thresh. Relative to the use of the motor types that currently exist. Next after that would be things like when you want to clean and when you want to winnow or drying the rice. The least opportunity for, based on our study is around when you are harvesting rice and of course when you're packaging. For cassava, the most opportunities for integrating, BLDC and PMS motors exist when you're peeling, when you're grating and grinding cassava, as well as when you're frying them. The least opportunities for integrating that exists when you're harvesting and packaging. And in the case of maize as well, the opportunities exist when you're milling maize, where a lot of the milling activities are done using induction motors. And from our study and our intervention with engagement, with stakeholders, we realize that during the milling process, a huge opportunity exists for BLDC integration during the milling process. All right. So one of the things that we did in the course of a study was to just run some case studies to look at where cost savings, both on the energy side as well as on the naira and kobo side, or on the dollar side, exist for integrating highly efficient, motor types into these three value chains. And we've seen in the case of cassava that you could save as much as 32% cost savings when you use permanent magnet motors when you're doing things like milling cassava. In the case of maize, you could actually even recover the costs for BLDC when you introduce BLDC motor into maize threshing operations in 17 months. If you do integrate things like permanent magnet motors, you're looking at 23 months where you're going to be able to recover the cost of buying the motors. And in the case of rice, one of the things that we found out with rice is that there are also huge cost savings when you integrate BLDC motor into rice milling. For rice, similar to what you find in maize threshing, BLDC motor types can pay back the upfront cost in 17 months. And in the case of permanent magnet, you're looking at cost recovery in about 23 months. Now, one of the things that we realize, in the course of engaging with stakeholders and as well as focus group discussions, is that even when you try to demonstrate that there are huge cost savings, there are opportunities for increased productivity and yield with the adoption of these technologies, BLDC and BMS motors, the number of barriers that would mitigating against the adoption of this particular technology types. One of that is the steep upfront cost of these motors. So in Nigeria, to get an average induction motors, you're looking at about $200, which is about like 300,000 naira. But if you're going to buy things like buy motor types like BLDC motors of the same comparable rating you'll be looking about $400. And if you situate this against the fact that an average small miller earns about, say, 300 or 400, or an average a smallholder farmer, based on the statistics from the National Bureau of Statistics, earns about $300 a year. That's quite a steep upfront cost for them. And even a lot of the millers that we interacted with during the focus group discussions actually financed their mills, their existing mills, using savings, and just about 10 or 15% of them were able to access loans to procure their mills. So one of the biggest challenges against adopting, these highly efficient motor types is the steep upfront cost. The cost is really high relative to, the regular induction motors that are available in the market. Another barrier that we noticed we observed in the course of our study is actually for the existing BLDC and PMS motor types or mills that are available in the market, the throughput capacity is still very, very limited. So the millers are particularly interested in like how much can these mills that are powered by BLDC and PMS motors, how much throughput capacity do they have? And from what we've seen, what currently exists in the market, the throughput capacity is still very, very limited. And for a lot of them, throughput capacity is like a major consideration for adoption. Again, there is limited awareness of these technologies in the markets, and I would say the paucity of information exists, across the value chain, from the policy making level, from the federal ministries of Federal Ministry of Agriculture and even the State Ministry of Agriculture. A lot of the bureaucrats in there are not aware, they're not quite familiar with these technology types, and that's actually a major challenge militating against adoption. As a corollary, we also notice that there's limited supply of the machines in the market, the motors in the market. So one of the things that we realized from engaging with equipment fabricators is that the machines, the folks who are stocking and selling the machines in the market, in the open market in Nigeria, are very, very limited, and they are not as readily available as you would have the regular induction motors. Now, another challenge is also the appeal and the user interface of the existing mills that are powered by BLDC motors. And I mean, it's even beyond the mills. Some of the existing agricultural equipment that are run using BLDC motors, in terms of just the appeal and the user interface, they're really poor. We use this particular phrase as they look like obese contraption. And then when you situate them against like mills or irrigation machines that are, run using the regular induction motors, you'll see the difference. And of course, that's also a challenge that militates against the adoption of these machine types. Now, end user preference is a big challenge for most people in the market. They would only see, what would appeal to them is what exists. And then even previous interventions that have tried to do retrofitting of existing equipment, to realize that there's always a preference of what they've always been used to for the farmers as well as equipment fabricators. That's a big challenge. And I remember in one of our engagements with an equipment fabricator that was building mobile threshing machines, we had asked that particular fabricator, why are you using a regular induction motor where obviously you're going to save more money on the long run by using a BLDC motor? And then we realized that for a lot of them, people are looking for multiple use cases, for adopting some technology. So they're looking for technologies that when they adopt, they have multiple use cases beyond just threshing. They can come back home and use the inverter or the batteries to power their TVs and some of the other equipment that they have at home. So that's also a challenge that we also experience. Now, the last notable challenge, or barrier militating against the adoption is also the limited after-sales support for existing, BLDC and PMS powered agricultural equipment. Unlike the regular induction motors where you have last mile support, even in the most remotest part of Nigeria, you have very limited support that would help, users troubleshoot their PMS or their BLDC equipment when they have issues. In terms of our recommendations that would help to mainstream adoption, we think that it's very, very important to solve the financing challenge. We think that it's important to have flexible financing options such as pay-as-you-go models that can drive adoption, and this will solve the barrier of the financing barrier around the steep upfront cost of these motor types. And the good thing in the market is that you have companies like Nimsy Solar that are building irrigation systems that are run using BLDC motors that have designed flexible pay-as-you-go options. We think that's something that is commendable that would also drive mass adoption of these technology types. We think it's important to leverage existing programs such as the Energizing Agriculture Program, which is an initiative of the Rural Electrification Agency in Nigeria. That program is looking for ways in which to ensure that farmers adopt efficient equipment for processing their crops. We think that it's also important to layer to see how collaboration opportunities can be exploited with the Nigerian electrification. I mean the World Bank's DERS program, which is a $550 million facility in Nigeria that has a component for productive use, productive use equipment. We think by leveraging those sort of programs, those sort of initiatives, it can increase the mass appeal of BLDC and PMS motor types. We think it's really important to devote resources and attention to increasing customer awareness of these particular technology types. So things like road shows, things like participating in agricultural fairs where you can exhibit these motor types would also help to increase awareness. Subsidy, they're very good tools that can also help to incentivize adoption of these particular technologies, both on the demand and also on the end user types. We think that designing subsidy programs or integrating these technologies into subsidy programs could also help enhance and increase adoption. And one other notable point to highlight is about the need to collaborate with important stakeholders such as equipment fabricators. These are major influencers that sort of determine what sort of motor types agricultural agro-processors adopt, and the same thing for farmers as well. So if the capacity building sessions are designed to also help to improve the capacities and the abilities of agricultural fabricators in Nigeria, we think it will also help to increase adoption of these technology types. Just to give you an example of some of the stakeholders that we think are available for collaboration that we can collaborate with to mainstream these technologies. They range from the Federal Ministry of Agriculture and Food Security. We have a number of government research institutions that have also designed and implemented interventions around designing prototypes for agro-processing and also locally fabricating agro-processing equipment. The Rural Electrification Agency in Nigeria is also a very important stakeholder that can also help to mainstream the adoption of these technology types. Again, at the risk of sounding repetitive, the equipment fabricators in Nigeria have a collective called AMEFAN, which is the Association of Agricultural Mechanical Equipment Fabricators of Nigeria. They have an association, and we think that the opportunities for us to collaborate with them to be able to help us to mainstream these particular types of technologies. And then, of course, the financiers. The financiers are very important. They're important stakeholder to help address the challenges around financing this equipment. And then one of the things that we've seen is that you have stakeholders like the Bank of Industry, folks like the Bank of Agriculture that are available. They're looking for opportunities to also drive mechanization in the food value chain. I'm going to hand on just some of the thoughts that we have around how do we get on the road to mass adoption of these technologies. We think it's important to convey a cross-sectional working group of various stakeholders, from the government side to equipment fabricators to financiers to agricultural research institutions, to start to think about how we can mainstream BLDC and PMS technologies. We think it's important to have pilots that can help us test the right business models to be able to mainstream these technologies, as well as ensure that they get to last mile areas where they are most needed. And of course, we think it's important to take lessons from those pilots to be able to feed into larger strategies for popularizing and mainstreaming these technologies. I'm going to pause here and yield the mic to Shalom. Thank you.
All right. Thanks, Ade. so much for your insights and for the presentation today. Again, you are all free to put down any questions that you have in the chat and the team can answer them, but you can also wait until the Q&A session and you can unmute yourselves and ask any questions that you may have. We'll now be heading over into our panel session. Our speakers for today include Mr. Samson Esuk from Nimsy Solar, Jennifer Anya from NOMAP, and Engineer Godwin Ogaga from Afrimash. You can go ahead and open your cameras and unmute yourselves as we head into the session. So starting with Mr. Samson Esuk, he is the technical lead at Nimsy Solar Agro Solar Concept, where he specializes in the integration of brushless DC motors with solar power technologies to drive innovative agricultural solutions. And he also leads the development and deployment of agro-enabled solar power systems, which include irrigation units, maize and multi-crop threshers, grinding mills, and solar dryer tools that enhance productivity while promoting sustainable low-emission farming practices. Mr. Samson Esuk, could you please give us a brief introduction of Nimsy Solar and what agro-processing equipment you primarily manufacture?
All right. Good morning, everyone. Hello, can you hear me?
Yes, we can hear you.
Yeah, good morning, everyone. My name is Samson Esuk, Nimsy Agro. I'm the technical team lead of Nimsy Agro. So a brief insight on Nimsy Agro. It's a growing organization that helps to improve smallholders' life, farming life. So just a minute. Good morning, everyone. Let me start afresh. My name is Samson. Nice to meet everyone. So the insight on Nimsy Agro, we are a growing organization that helps to improve the lifestyle of smallholders farmers by making farming experience a bit more friendly and profit-saving for them. So Nimsy Agro comes up with machines, solar powered equipment that helps to make the farming life much easier. And these equipment are mobile and also stationary. For those remote places where electricity is not very much available, we have mobile machines that uses solar as well that can be taken down to the farm and then they can make use of it as well. Thank you.
Thanks for that, Samson. Over to Engineer Godwin Ogaga, who is the Engineering Procurement Manager at Afrimash Company Limited, where he leads the sourcing and deployment of clean energy solutions and agro-processing technologies that support smallholder farmers across Nigeria. Engineer Godwin Ogaga, would you be able to give us a brief introduction of Afrimash and your support for smallholder farmers?
Thank you very much. It's a pleasure being here. And good morning, everybody. I am Godwin Ogaga. I'm actually a mechanical engineer, and I am the procurement lead at Afrimash Company Limited. So Afrimash is one of Nigeria's leading online platform. And we are dedicated to this, like that they need to thrive. Like basically what we do is we verify agro processing equipment, because we try as much as possible. We need to understand the technicalities behind what we are actually putting out there. So of recent, we started concentrating more on clean powered energy machineries, and that is clean energy powered machinery. And we also give technical support, trainings when necessary, and most importantly, it's always about the after sales service. That is to ensure continued usability and to make sure there is no downtime, especially during their peak period, because we understand how agriculture is, when there's always a season for everything. So during the course of let's say, for instance, when it's not a season for a particular crop or product, there's always downtime because the machines are always slow, they run slowly. So they don't understand the maintenance culture behind it. So we always make sure we have all these after sales services on standby, because during their peak period now they start using these machines and there's always a lot going on that period. So the basic challenge is always having this after sales service, not even giving them the machines. So Afrimash, we are very big on that. So far we have engaged in more than 30 communities, rural communities especially, across Nigeria. So we don't just deliver equipment to them, we also sit down with the farmers, we listen to their needs, we understand their energy constraints, and we could create solutions together. So basically, that is for Afrimash company. Yeah, I can go further if you need me to, but for now, I think I need to pause for others to also contribute.
Thank you so
Thank
much
you.
for laying that emphasis on after-sales service and the role it plays in continued use of the technologies that you sell. Over to Ms. Jennifer Anya, who currently serves as the Program Associate at NOMAP, which is an independent off-grid market accelerator co-created by the Shell Foundation and USAID, where she supports efforts to expand energy access in off-grid communities. Ms. Jennifer, would you be able to tell us the role you see finance playing in accelerating the adoption of energy-efficient motors in agro-processing, particularly for smallholder farmers and rural processors, and how NOMAP is currently supporting that?
Yeah, sure, I can do that. Please confirm you can hear me before I go ahead.
Yes, we can. Thank you.
Oh, perfect. That's good. So financing particularly plays a critical role in accelerating the adoption of energy efficient motors, particularly for smallholder farmers in these rural communities, because they are pretty much the ones that face the barriers regarding accessing this processing assets, basically because of the upfront cost, despite the long-term benefits of its improved efficiency. So with that, you start to see, as a result of that, then comes lots of food waste, because this food costs can't exactly be processed into ways you can sort of store them and use them for long-term use. So based on that, NOMAP then came in and then took a research initially to sort of understand what support we can give, we can sort of allay to these farmers. And we sort of rolled out a pilot, which we termed the Agro Integrated Facility. Right, so this facility essentially supports mini-grid developers or off-grid energy companies in rural communities to be able to sort of play a role in the value chain, in the agro value chain in the communities where they have their power systems existing in. So what that means is it sort of helps the rural customers or the rural farmers in that location to sort of bring their produce to the processing facility and then process. But then the interesting thing about that is the farmers do not, in this sense, end up worrying about off-taking, because all they need to do is just to bring their own farm produce, raw as the case may be, to the farming processing center created by the mini grid company or the off grid energy company in this case, which in some cases the mini grid company or the off grid company goes ahead to create some arm that sort of deals with agro value chain within the community, where they then offtake this produce from the farmers. So in that sense, we started to realize, or we started to see instances where there was reduced cost sharing, because farmers no longer had to worry about having to sort of sell or look for where to sell their produce to. And we started to see it was a bit more affordable to them, because they no longer had to think about how to sell and who to sell to, and then the cost of diesel, because you've come to understand that the farther you are from the city center, the more expensive it is for you to buy diesel. Right. So that was some of the issues that we had. And then with crop seasonality for the processing plants in this case, we started to sort of think around how we can make it a year-round utilization, where farmers can sort of bring other crops, where it could even be like a use case where these processing facilities could do more than just one processing of just one agro crop. So, I mean, in that case, we then understood and saw what these benefits were to the farmers, because even with some of our conversations with the beneficiaries of this facility that we deployed, you can even see that it even went as far as even extending economic development or economic activities to the other secondary arm, not necessarily related to agribusiness, but people that sell like bags that you can sort of bag your produce, they start to make more money, right? They realized, or the farmers will come back to tell us that, oh, that their farming produce fetched a lot more value in the market compared to the ones that were sort of refined using like manual ways and all that. So those are sort of the, what I say, reviews or some of the feedback that we got from the developers based on having to have deployed this initiative. So, I mean, based on that, we sort of understood that, okay, there is definitely a way that marrying energy access and agro value chain goes in a hand to sort of expand economic activity within a state or within a locality, as the case may be. So I think I'll pause here, just, I mean, answering the question that you sort of asked.
Thanks, Jennifer, for that, and for also highlighting the downstream impacts for individuals who might not be directly using the technologies that are being sold, but also benefit from it in terms of their livelihoods as well. Back to Mr. Samson Esuk. Given our discussion today on high efficiency motors, how is your organization integrating off-grid adaptability and energy efficiency into your products while also considering the end user and the costs they would potentially incur?
Thank you very much. To answer that, we provide solar machines, like I said earlier, and these machines include irrigation pumps, dressing machines, maize threshers, to be precisely. Then we have multi-thresher as well, and also hammer mill. All these machines makes use of solar powered. So for the irrigation pump itself, it's basically solar powered. There is no battery attached to it, it's just solar powered. So it will work very well in an off-grid community, and it will help them very well in farming. And as well as of the threshers and also the milling machines, we integrated them with an inverter system so that it will be able to work for them in an off-grid community. And it also comes with a panel to charge it as well, just in case the battery is going down. Since there's no NEPA or power supply in the community, they can also use the solar panel, which is available for them, to charge the battery and also continue the work. Thank you.
Thank you, Mr. Samson. Heading over to Afrimash again. What are some of the farmers' perceptions of diesel-powered agro-processing equipments in comparison to solar-powered equipment?
Please come again. I didn't get that. Sorry.
No problem. So what are some of farmers'
Hi,
perceptions?
Shalom.
Hi, Godwin. We can hear you.
Okay.
Right, I'll repeat the question. What are some of farmers' perceptions of diesel-powered agro-processing equipment versus solar-powered equipment?
Oh, that's a very good question. Thank you very much. Well, this is actually a particular question. It's a topic that has caused so many debates in literally every community we visit, being on field. Well, the perception there is we to really school them, teach used to, and for the farmers, diesel power works well, yes. The cost is killing, no doubt, because diesel is not cheap in Nigeria. And the thing is, to them, they can always find fuel. And when they do, sometimes it's expensive, it's adulterated. Now, these are the parts we point out to them because they always tell you, oh, it's powerful, we can always get fuel. But another thing, we started explaining the noisiness. Because most time when they're even using it, they can't hear themselves because you have to shout over the engines and all. Then it breaks down a lot because now you have carburetor issues, you have belts, you have smoke. So all these things are things that was a challenge. So while diesel machines are powerful, they come with so many ongoing professional operational burden. As we are talking of the high cost, many they didn't really see themselves as being trapped in that particular circle. But while we started introducing the solar power energy efficient electric equipment, now what they say is when they started using it, the started like, to them, let's just see, because many of them, they are not privy to most of these things. And for one thing, it was quite strange to them at first because now they could see the benefit. It's quiet. Like you can discuss with your customers while you are doing this, like more conveniently. And you don't spend money on diesel, you don't spend money on fuel. And the sun, once the sun is up, like once the grid is charged, they are good to go. Like it got to, and it saves money every month. So it got to a point we started having individuals and farmers who actually want like independent solar powered, using these motors now for these machines without having to in a location where they do not have mini grid facilities. Like when they started seeing the benefit, like they want to take it to other places, they want to utilize it there, but we don't have mini grid. So how do we get these machines down there? So like that is a growth in the shift of mindset so far, because initially farmers were skeptical about the solar powered machine, particularly using the brushless ones, because they didn't even understand any of these things. But when we started showing them the positive part of it, and after our demonstration and pilot programs where they see these machines and equipment work, now the confidence is building so rapidly that so many of them have these machines that they actually want to convert, and they can't even convert that because the particular facility, that is a mini grid facility they have, cannot actually sustain the power of what they want without tripping up, because these are really big machines. So the mindset is shifting, and gradually they are seeing the advantages. Thank you. That helps.
Thank you so much, Engineer Godwin, particularly on laying emphasis on consumer engagement and training and how that influences the uptake of appliances, but also what you had mentioned on the cost savings and also noise that comes from the diesel-powered machines, and then how that in turn impacts their quality of life. So all of those are really important things to consider as well. Over to Ms. Jennifer. Would you be able to share learnings from NOMAP's Agro integrated facility that funds developers to deploy and operate agro-processing facilities? What financing parameters did NOMAP pay attention to, and what has been the end user's perception of the electric-powered mills?
Yeah, sure, I can definitely do that. So based on the learnings we sort of got from that and the financing, do I say understanding of how we sort of roll that out, I'll start by sort of laying out some of the financing parameters that we sort of paid attention to. First off, it was more or less like the viability of the agro-processing agro-processing plants in the mini grid location at this point, because essentially, as my colleague had earlier mentioned when he was presenting, various food crops in Nigeria grow in various regions. So it was important for us to understand that the agro-processing plant that was going to be deployed in each of these communities was pretty much evident in the farm yield and the farm crop that was evident in the locality in itself. And on that end, it was even understand in what quantity, because you put up a processing plant, but then the quantity that comes from the soil from the farmers is not enough to sort of service the processing plant that is in existence there. And on the other hand, with regards to the mini grid facility in itself, it was important for us to understand the health of these mini grid companies, right, of the mini grid system in itself, because the agro processing facility in its case was one as such that the processing facility was going to be taking power from the mini grid system. So as much as the mini grid system is supplying power to the community members, it was also supplying power to the mini grid, to the agro processing facility. So it was important for us to understand the health of the batteries, the health of the solar panels, the health of the inverters and the rest of the assets in the system, because at the end of the day, this is a system that we expect to sort of run for quite a number of years, and then you end up realizing that some of the systems that these agro-processing facilities were attached on had already been in existence for maybe say 2, 3 years or 4 years. So it was important for us to understand that the batteries were still in the right frame of mind, or sort of still in the right health. It was also important for us to pay attention to risk management, sustainability as well. So as much as we funded the developers, we also made sure that they also had some level of equity in the game, because that would in a way assure us that they were going to pay a lot more attention and ensure that we're getting the right parameters and getting the right reports. If certain things are not done right, they'll pay a lot more attention to that compared to when it was sort of maybe just a grant money or something that they didn't necessarily have some skin in the game. It was also important for us to pay attention to sustainability, I would say, in the sense where outside of just processing, how do you ensure that there is constant use of the facility in itself. How do you ensure that the farmers have the time to go back to their farms to farm a lot more and then bring to the processing plant? So this was in the sense that we then had conversations with the developers to say, can you, rather than just processing, can you offtake the produce from the farmers, right? So you source the outside, you source the off-taker markets, you do all of the business around aggregating whatever demand that was and just taking from the farmers and selling to the populace in that case. So those are some of the things that we paid attention to. And in terms of feedback from the community members, like I earlier mentioned before, there was some form of extension of even economic development to the non-farming markets in that sense, where the people that paid attention to logistics were doing a lot more because people were selling a lot more in there because there was a lot more traction was coming from the agro-processing plants compared to when it was just the diesel, where they had to depend on availability of diesel, and then it was in small tranches because this processing facility could cater to a lot more compared to the other processing facilities that were powered by diesel, where they were just in very small nooks in separate areas of the communities. There was also final produce because then it was not produced in a final way. There was no they could it was with rice particularly, it was polished in a lot more finer ways as we got feedbacks from the developers that we spoke to. For the peppers that we also funded, we saw that apparently they could sell a lot more, right? So it sort of opened up the market to competition in some sort of way because at this point the farmers could sell. They were making a lot more money, or rather, they were making a lot more produce, and then it was sort of causing some sort of competition in the markets, and then, of course, lowering the price of peppers in the long run for the off-takers. I think, and also, I mean, in terms of the fee that they had to pay to process as well, it was such slightly a lot more reduced compared to the diesel processing plant, because with diesel, the prices were sort of undulating because it was sort of pegged at whatever was available. And in Nigeria at the moment, there's been sort of some stabilities with regards to the price of diesel and whatnot. But then with the processing facility that was sort of powered by the solar mini grid, it was a lot more stable on that end. So they could sort of just pay a fee and then come process their food crops. So that's it. So with regards to some of the learnings that we took out of here, it was for us to understand that agribusiness, agriculture and energy is more or less like a nexus. It's never in isolation of each other. And we've come to realize that majority of where mini grids are existing are in the rural communities. Where our food comes from are in the rural communities. So it's important that as much as we're also scaling energy access, we're also doing it in tangent with agriculture as well.
Thanks so much, Jennifer, for that response. And thank you to all our panelists for sharing your insights today. I think you've all touched on the importance of considering cost and user experience as we deploy solar-powered equipment. So maybe a final statement from each of you on any other things you think we should consider as we target farmers in Nigeria with high efficiency motors and solar-powered equipment. Maybe Samson could go first.
Okay.
Sorry, please, can you repeat the question again?
If there's anything you think we should be considering as we target farmers in Nigeria with high efficiency motors and solar powered equipment.
Sorry, please come again. The network is not steady.
Oh, okay. Can you hear me?
Yeah, I can hear you now.
All right. The question is whether you had any final statements that you'd like to share on what we should be considering as we target farmers in Nigeria with high efficiency motors and solar powered equipment.
Yeah. Okay. Yes, I have some insights on that. Targeting farmers now with high efficiency motors, bro. It would be better if they can make the brushless DC motors available for farmers to use because of how efficient it is, number one, and how the energy used to power it is. For BLDC motors, it doesn't need the grid line to power it. Your solar is enough for it to power. So if they can make it available for farmers, I think that will go a long way.
Thanks so much, Samson. Jennifer, do you wanted to share something?
Yes, I was going to say that I think there's some level of lack of awareness, and I would say that we need some level of really innovation in in the sector with regards to brushless DC motors. Everything that's based on our feedback and our conversations with the smallholder farmers, they are very much comfortable with what they know, which is the diesel powered bit. And majority of the brushless DC or even the recent type of technologies that are sort of advancing are still very much in their very nascent state. So you don't exactly find them very much mainstream, and they all look like they've just been contracted together. There's just no standards that sort of says this is the way to go about it. Um, and even in the availability of brushless DC motors as well. I don't know if I think my colleague must have touched on that earlier. It's almost fairly difficult to even find it in Nigeria at this point, where because majority of the ones that you find are mostly gotten from um, some appliance, mostly treadmills and every other appliance that is sort of runs on DCs, and they sort of range between the zero, maybe 1 kilowatt to under 5 kilowatts, maybe 3 kilowatts. So nothing really goes way above 5 kilowatts sort of targets when it's a bigger processing and bigger processors rather. Um, then with regards to the farmers, I would say financing. Um, it's quite unfortunate that a lot of the food that we eat comes from them, but then they're still the poorest on the value chain. So putting the money in their hands, putting the resources in their hands to enable them be able to scale, right? Which sort of calls for the need for Bank of Industries, African Development Banks, development partners, and I think it's also important. I think it's just recent that energy has just started going in tangent with agriculture. Previously, it was just a standalone. But the more that we sort of marry all of these things together, and it doesn't always have to come from a mini grid facility, it can be a standalone, like what the folks at Nimsy Solar are doing. So, but then if you look at the cost of these appliances on their end, it sort of ranges into the millions in naira, right? So, but then it's not affordable for the farmers to be able to access. So, financing sort of plays a very big role in enabling access for these machineries. Yeah.
Thanks so much, Jennifer. And Godwin, to close, if you have any final statement on that as well.
Oh, yes. Thank you very much. I totally agree with Catherine, because sincerely, from my personal experience on the field, truth is, yes, they have mini grid facility. Will provide them with that, and yes, that makes their life easier. They have what they farm in, that makes their life easier. But see the twist here. You know, when you are going to provide any of these electric motors, it starts with, first of all, understanding the mini grid facility itself. So because it's the particular rate of power, that at this point we work very, very side. So because now we are not providing the machine based on its capacity, because if a user comes to you and says they want 1 ton per hour, kind of, let's say, rice mill machine, and the mini grid facility is like a weak one that, you know, the motor is not, you cannot give a 1 ton per hour machine to that particular grid facility. They might just come back to probably a capacity, or yes, a power capacity that can work, let's say, around 3 horsepower, for instance. Now you're starting from the machine to the equipment itself based on the capacity of the mini grid facility. You understand? You're not giving the machine based on the electric motor. So now this is the point. When they provide this machine, at all times, these farmers, they want to buy equipment to be able to consume the power. They want to have a. That's where financing comes in. But this is the point. If a particular, I'm also a supply chain professional, so preparing a solution. For instance, I'm coming to give them a mini grid facility. I've already put in mind that, okay, this is the kind of facility I want to give. This is the kind of motors they can support. What do the farmers grow? What do they do? Because many of them, they want to be able to grow their crops because that's majorly what they do. So I'm looking at it like, I just drew like a very simple plan, like provide, before you even provide the mini grid facility, you provide their fertilizers for them to be able to grow their crops. And when you give them fertilizer, you help them grow their crops while there isn't a machine. This fertilizer will help them be able to grow healthy crops, which they might not be able to pay you back in cash, but they can pay you in their farm produce. If you also want to make more profit, you provide the machines that they use for processing. You give them the machines based on the capacity of the mini grid facility. Meanwhile, while you give them all these things, you also stand as an off-taker because that's the end point. If they can pay in cash, they pay in their farm produce, which you will get. And when you get their farm produce, even after processing, when they come to process, if they can't pay in cash, they farm produce. Sorry? I lost you for a moment there. I didn't get that.
I think your bandwidth might be a bit low. It's breaking a bit.
I'm sorry, I didn't get that. Oh, I am sorry about that. So the point is,
maybe you should turn off your video.
Can you hear me now? Okay, yes, that. Am I audible enough?
Yes.
Oh, thank you. So the idea is you give them fertilizers, you give them this farm equipment and inputs based on the compatibility of the motors with the facility. Then when you also take payments in farm produce, when they come to process, you also take payments in farm produce. Meanwhile, you are storing them somewhere. At some point when they start working with these things and you're not giving them for free, they have their cooperative communities, which they are always all that can run this thing. So in as much as they want to pay in cash, you can also take them in farm produce, because the point is you're giving them energy. They should be able to utilize the energy, and they will be able to utilize this energy if they have what to sell, which is their farm produce and most of
me or
person.
anyone else?
Sorry? Please, am I audible enough?
We can hear you, Godwin.
Okay. So when we have all this put in place, I don't think we'll be able to utilize or help them utilize the power more, because many of them want to do so many things, but it's credit financing that is a problem. And they are not even asking for you to give them the machines yet. Once they can go their farm produce, they will sell those things and be able to purchase this appliance, this equipment, because many of them do not really understand what's fertilizer. That's my major take from my engagement with them. Thank you. I just hope this helps. If there's any question, I'm very willing to also answer.
Okay, thank you so much, Godwin. As we are at time, in case there are any questions from the attendees, maybe we can take one. So if you do have a question, you can raise your hand and we'll address it before we close for the day. All right, since I'm seeing no hands raised, thank you so much to our speakers and panelists for today and for the NOMAP team for their work on this. In case you'd like to reach out to any of the team members to get some more information, do let us know and we'll share with you the contacts that you could reach out to. And the PowerPoint will be available on demand. Thank you to our attendees today for your time and for listening in. And we can close at that point. Thank you all.
Thank you very much.
Yeah, thanks everyone. Bye.
Thank you, everyone.